Everybody, just to start with, just slowly warming up your brain, would you write down square root of 49 and then write down what the answer is? Some people will think of this as, get out of here. We gotta work on the math right now. It's day 1, minute 1 after break. All right, so some people think of square roots as like the opposite of squared. And that's true, because 7 squared is 49. The answer to this thing is 7. So there's no doubt that square roots and squared are kind of similar. But if I said x squared equals 49, then you'd say, oh, the answer is 7. But it's also negative 7. It's really easy to forget that one. 2-second reminder, if I square root this, you get absolute value of x. And then that breaks into 2 answers. X is 7, x is negative 7. Do you remember that kind? All right, so let's try one of those. X squared is 100. So you square root, and then the first thing that happens, some people are going to forget that the first part is not x. They do undo each other, but the answer is absolute value of x. All right, square root of 100 is 10. And then you break it into 2 parts. Those 2 equations will be identical. Do you need help? Okay, so do what I did on the iPad. If your Apple Pencil is dead, use your finger. 90% of the kids in here are using their finger, and it works fine. You got 2 answers, x equals 10 and x equals negative 10, and notice there's only one difference between these 2. That negative. That's the only difference in those 2 equations. So when it goes to here, everybody copy this one down, x minus 3 squared equals 9, and we're going to square root both sides. Takes a little bit of time to get back in the groove. Square root both sides. Square root. And it's not just x minus 3. You've got to get used to the absolute value. That is a critical part. Say, what's the square root of 9? 3. So this is 3. And now, Sam Lowe, you got 2 equations, and they are identical, except for one negative sign. Can you tell me what they are?
Would it just be x plus 3?
Nope, minus 3. The sign is on the other side of the equals. See, this is identical in both equations, x minus 3 and x minus 3. Okay. This is equal to 3 in the first case and negative 3 in the second case. Do you see the only difference is right there? Just that one thing is different. But you did do what is very common for people to think, oh, I'm going to change all the negatives. No. You just put in one negative. That's it. All right. And now I have to finish this thing by adding 3 to both sides. And x equals 3 plus 3 is 6. Add 3, and x equals negative 3 plus 3 is 0. Those are my 2 answers. This is one of those tests where you can also check to see if you're right. So if you cared about your grade on this test, you just take a second and go, I wonder if 6 actually works. And you go put it back in. And my original problem was this. And I said, I thought 6 worked because it says it 6 works down here. So I check it. I go 6 right there. 6 minus 3 is 3. 3 squared is 9. Ha! It worked. And I can check the other answer, which is 0. And I just put a 0 right here. And then I'd have negative 3 squared, which is 9. Yay. All right, little things that kids do wrong. kids think that that's 4? Why isn't it 4? Shouldn't 2 squared be 4? This would be 4. If it had parentheses, then it would be 4. It doesn't have parentheses. What is it then?
Negative 4.
Negative 4. Okay, that's a really, really important difference. Do you see the difference? If you got the parentheses on it, then it'll come out positive. If you don't, it'll be negative. Just reminding you of all the little things that are going to come up on the final. Okay, so our next test is about solving these squared things like we just did. That's one of the topics. And our next test is mostly about quadratics. So the next thing I got to teach you tomorrow is called the quadratic formula. It's that x equals negative b plus or minus square root b squared minus 4ac all over 2a, that gigantic formula. We will give it to you on the test. Yay. So you don't have to remember the 16-part formula. You just have to be able to use it. Or stick numbers into it. Okay, so that's the last big thing. And we don't have the test until a week from tomorrow. So we got a fair amount of time to like get ready for that test and then take the last test. But then you only have like 3 days to prepare for the final. And the final covers everything in the whole semester. All right, so this little review that I'm doing right now, every single one of these things are things that will be on the final. So I'm just trying to throw in a little bit of help getting you ready for the final. All right, let's see if you remember this kind. Square root of 20. Well, I don't know what that is, because 7 squared is 49, 6 squared is 36, 5 squared is 25. That's like the closest I can get. So then you break it into 2 square roots. Do you remember this guy? Rominsky, what are the 2 square roots that you chose? There's 2 options. 4 and 5 was the right call. Is it about just getting lucky? Well, kind of. If you tried root 2 and root 10, you'd realize that neither one of these works out. So don't pick that. That works out. So it ends 2 root 5. Remember those? Okay. Do you remember what happens if they're negative? Like square root of negative 27. Everybody write that one down. This will be a really important one. This should be one of the easy ones on your test, because all you got to remember is the letter I. Oh, no. It'll be just like the other one we did, except there's an I in the answer, because it's an imaginary number. A reminder, you can't do the square root of negative 27 like with a normal number, because you'd never come out to negative. Like if you had negative this and negative that and you multiply them together, that comes out positive. There's no way to do square roots of negatives unless you know this. Make 3 square roots. One of them is negative 1, one of them is 9, and one of them is 3. Process that for a second. Do you remember this? Remember doing these? Well, it's been a while. That might be tied with the longest break there has ever been in 34 years that I've been teaching. So, like, that was an amazing long break for you guys. Because of that extra day at the very end after the 2 weeks where you guys got to stay home, we had to come back and work. That extra day, I think, pushed it to 17 days off. That makes it really hard to come back, but that's I, that's 3, and that's square root of 3. I would have accepted this answer, but it looks a little backwards to anybody who knows what they're doing. It really should be 3i root 3, just so you know. I would have taken the red one, but the blue one's the way you're supposed to do it. To get if I said x2, it looks a little weird compared to 2x. 98% of the time, isn't it 2x? Yeah, the number's normally first, right? So 3i is more logical. Not worthy of marking this wrong, perhaps, but it's better to have the number in front. Make sense? All right. So what else did you know before break? Well, we had quite a few kinds of questions. Sometimes they had a little something to do before you take the square root. Everybody write this one down, please. See, you don't go start with the square root on this one. Why not? Because you're supposed to do any add or subtract that you can do first. I'm just going to remind you why we're supposed to do something first before the square root. When you're solving an equation, you're doing PEMDAS backwards. You ask yourself, could I add or subtract anything? I know there's a few kids who think that you could add 7 at both sides, but you can't because it's being squared. So you cannot add or subtract anything. But you can multiply or divide something. So I think most of you knew that you were dividing by 2. I'm just reminding you why that's what you do first. And then once you're done with the multiplies and divides like that, and of course 8 divided by 2 is just 4, then you're ready to handle the exponent. And how do you get rid of that exponent? With the square root. So then it's square root, and this is absolute value. Square root of 4 is 2. And from there you have 2 equations. Finish this off, everybody. Take a second. Finish it from there. Paloma, the first equation is just exactly what you see without the bars.
X is 9.
That is not an equation.
Oh, X minus 7.
Equals.
Oh, 9.
Nope. Look, right there. That's the equation. X minus 7 equals 2. That's the first equation.
Oh.
See, it's just the same thing we had without the bars. And I know, then you solve it and it comes out to 9, but that's not the question. The question is, what's the first equation? Now, what's the second equation? It's identical to the first equation, except this isn't 2, it's negative 2. You see how the red equation and the white equation are identical except for this one negative sign right there. Okay. Ash, can you tell me, oh, we already know this one comes out to 9. What's the other one come out to?
5.
Oh, plus 7, and x equals 5. I can verify you're right. If you weren't sure because you didn't have a teacher to verify it, you go stick a 5 in here and see if it works. 5 minus 7 is negative 2, but the absolute value of that comes out to 2. Yay, it worked. Even better, you could stick it into the original equation, which was way back here. And we think 5 is an answer. We go stick 5 here. 5 minus 7 is negative 2 squared. Since it's in parentheses, comes out to positive 4 times 2 makes 8. Yay! I know it works. All right. So we're almost done. We're almost done reviewing everything that we learned. There was a couple more things, though. There was some stuff about I. Anybody have a short-term memory and remember what I squared is equal to? Negative 1, a bunch of you. That's nice. So when you have this, 2i times I plus 4, the first thing you do is just multiply out like a normal variable. But whenever I squared happens, you put in negative 1. Okay, so try this one. Multiply this out. 2i times I. Sadly, a lot of kids get stuck on that. They're like, I don't remember how to do 2i times I. It's 2i squared.
Is that twice I?
Nope, it's 2i
together?
squared. Like 2i, and then since the I is times an I, it's I squared, like that. 2i times I is 2i squared. Bennett, what's the 2i times the 4? This times this. 4 times the 2.
8i.
8i, there you go. And then, what's this thing about I squared again? Marshall, do you remember? So So if that's negative 1 times the 2 makes it negative 2 plus 8i. And I gave this dumb example of, but it's getting more and more real every day. There's going to be robots walking around that look like humans and humanoid robots, and the real are going to go first. There are already some interesting case law about like, are robots that are, do they have any rights at all? Right now they pretty much don't. Like if there's a robot, if you own it as property, it's like you own a lawnmower. It's like if somebody steals it, yeah, they can get in trouble, but if they destroy your lawnmower, all that happens is they owe you money back. Someday maybe the humanoids might be sentient. But I hope the real part stays first. So bottom line is you should not ever write 8i minus 2 because that puts the imaginary part first. The real part's supposed to be first. This is how you do a complex number, with the real part first. All right. So then once you do that, then it seems like everybody thinks that all the problems are multiply after that, and they aren't. That is not a multiply problem. You aren't going to multiply anything. You're just going to add. One of the easiest problems on the test, for sure, if you don't multiply. The trick is to don't multiply these. Kind of feels like you should, but you don't. Because S is plus. You just drop off the parentheses. You can do that, yes. I know it's really rare. Almost never just drop parentheses, but on this kind you do. Because there's nothing multiplied by the parenthesis, and nothing you can do in the parenthesis. Like you can't add an I and a 4. Like they just have to stay separate. So then you can add like terms. Please put those together and put the real part first. And compare your answer with the person across from you. You're going to be doing some group work with the person next to you as part of your homework today. So remind yourself that you have other humans to work with in this room. So it's these 2 rows straight across. In your case, you're going to go diagonal and work with Esh. And then you 2 guys can work together. These 2 rows, talk to that person straight across from you. Get it finished up. If not, I'm going to play. Talk to that person next to you. You know who it is. In your case, it's
I was in the wrong class. It's not a quarter.
Oh, you're thinking of second hour? Oh,
Sorry.
interesting. Okay, no problem. Have a good day. Okay, what's I plus I? It is not I squared. It's I plus I. 2i. What is 4 plus 2? 6, but shouldn't the real part come first? 6 plus 2i. Raise your hand if you had 6 plus 2i. Okay, awesome. Now, what if it was actually a multiply? I plus 2 right next to an I plus 4. What if it was multiply like this? Then it's way harder. First you have to multiply out 4 things, and then you add the like terms. Take a second and try one of those. You learned a lot before break. This is one day before break you learned this. And we're almost done. There's basically just one more thing you have to learn, or relearn. I times I squared. And yeah, it's going to turn into -1 in a minute. I times the 4, 4i. 2 times the I, 2i. 2 times the 4, 8. Now that's -1, and that's an 8. And a -1 and an 8, it's like 8 minus 1. So that's 7, and the real part comes first. Plus 4i and 2i is 6i. All right. Hopefully your brain's slowly coming back to life as far as math goes here.
Wait,
Question?
how'd you get 8 instead of, how'd you get 7?
Because this is a multiply, and that's a 2, and that's a 4, and 2 times 4 is 8.
Oh, yeah. 7.
How did it get a 7? Because this is -1. Remember that I squared is -1 thing? I know, that's a lot to put all together. Maybe I should have showed that this equaled -1 first, and then put them together. Tried to do 2 steps at once, and I've confused you. All right, then the last melon. Is 4i a 0 of this function? So we give you a thing, we ask if it's a 0, and then we give you a function. Now, if it's a 0, you should stick it in here, and if the answer comes out to 0, it was a 0. So all you got to do in this kind is stick this in here and see if it works. See if it really equals 0 like it says it's going to. All right, so I'm going to put in a 4i right there in a parentheses because those matter. Parentheses matter a lot in math. And any variable is like an empty parentheses. So I just stuck in the 4i. Now, it does kind of seem like it's going to come out to 0 because you know I squared is -1, right? But this is not a 0. How do I tell it's not a 0? Because 4i squared is 16, because the 4 has to get squared. That's a really common oops, is that number has to get squared. So that's 4 squared is 16i squared, and the I squared is -1, so then that makes this -16 plus 4. That is not a 0. It looked like it was going to be a 0. It's not a 0. Because this doesn't actually equal 0, does it? I mean, that and that doesn't equal 0. So this is not a 0. All right. Here's the most common mistake on these. If I said, is I a 0? People know that they should stick the I in. Everybody knows that. It's the squaring it part. So, what is I squared? -1. And what is -1 minus 1? Is it really 0? See? That's not 0. -1 minus 1 is not 0. So this is not a 0. So there's 2 things you could do wrong. Either you square it wrong, or when you look at it, you like do it too quick and you go, yeah, 1 minus 1 is 0. No, it's -1 minus 1. That's not 0. So I was not a 0 of this function. You stick it in, you square it properly, and then you just read this carefully and see, does it really equal 0? Sometimes it does, sometimes it doesn't. All right, so you have relearned a whole bunch of stuff. Now, I am going to give you the little, it's just a review worksheet with 8 problems, 1 of each kind. And I'm going to give you a partner. And I'm going to ask you to slide over next to that partner. And you guys are going to work together till the end of the hour. If you finish it, awesome. If you don't, it's your homework. Slide on over. Slide on over, gentlemen. Slide on over.
Looks like we have anchors. That is nice. I don't know why.
Slide over next to each other.
Well, no, it's a
I know, but we have
Okay, slide over next to each other.
But yeah,
Slide on over.
I honestly.
Oh, you're so lucky. You know, I was busy. I'm looking for something to talk over all 17 days of work, so I just didn't have time.
Two of them there. Bash them on up here.
So Sam, what we do is simplify the process first. So let's do 5 4 first. And you know that 4 creates a fuzzy 2. And since there's already one on the outside, so you gotta multiply. So it's 2 times 4 is 6. You take this one, and that's just 2 times 2.
If you get stuck, if both of you are not sure what to do, call me over. I'll give you the first step. I'll help you get going. That's all I got for you for today.